We are starting to get a little more confident now with finding or taking the z-score and finding the area or the probability or percentage, however you want to think of it, how it correlates to that z-score, that standard score, that z-value. But now we want to work backwards. So now we're going to try to find data values given those probabilities, given those percentages. So let's look at an example to see how we're going to do that. It says to qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify, and we're assuming, of course, it's normally distributed. I really do encourage you to sketch a little picture of the standard normal curve. Because what we want, it says candidates must score in the top 10% on a general abilities test. So the top 10% is going to be right here. It has a mean of 200, standard deviation of 20. But think about this means. Remember, the area under here is 100% or 1. So the top 10% is over here. Remember how we read this standard curve, or however you want to think of it, is we want the area up until this point. Remember the chart, the standard normal distribution chart, is the area, the percentage from the left. So to actually find this value, we want to work backward. Okay, normally the last thing we do is look on the chart to find things. Well, it's almost like that's going to be one of the first things we do. But we also need to start by going 1 minus this. And then let's talk about why we do that. Obviously, that's going to be just 0.9, or we'll add some zeros here because it matches up better. The reason we do that is because if we're going to use the chart, we need to understand that the area is from the left to whatever our value is going to be. So what we have here is the area to the right, so we go 1 minus it to get the area to the left. Once you have this number, okay, that's the area under our curve up until our value here, go to your standard normal distribution chart and find where this number is. So we're not looking at the axes here, we're kind of looking at all the numbers. It's to the right of the mean, so we know it's going to be on the positive side. And what we're going to find is it's not exactly on there. There isn't 0.9, 0.900, but we do have our closest value is 0.8997. You're going to see it occurs between 0.8997 and 0.9015. This is the closest value. Okay, that's going to mean our z-score correlates to this value, which is 1.2, and then up here 8, 1.28. So now we have our z-score. Just a little hint. If the area or the percentage or whatever, remember it's all basically the same thing, falls halfway between, use the bigger number, or use the larger number. In this case, it was closer to this one, that's why we're going to use this z-score, but if it was exactly halfway between, bump it up to the higher one. Anyway, alright, so we found the area we were looking for, we went to our chart, found that area, see what z-score it correlated. Now, use our formula. Remember our formula, the z-score is going to equal, let me rewrite that. The z-score is going to equal whatever the value is minus the mean divided by the standard deviation. Now let's fill in what we know. We know that the z-score is 1.28 or 1 in 2800ths. We do not know the value, but I can subtract off our mean right here of 200 and divide by our standard deviation of 20. Solve it. Multiply each side by 20. When you do that, that works out to 20, right over here, 25.6 equals x minus 200. Then add 200 to each side, and we get that x is equal to 225.6. What does that mean? Find the lowest possible score to qualify. Well, we're not going to leave it as a 0.6 here. We're going to round up. And the lowest possible score to qualify would be 220. I'm going to say 6, because we're not going to get 6/10 of a point. So the lowest, 226, represents the lowest score to qualify. Okay. To qualify. But anyway, again, in this situation, what we're doing is we're working backwards. Okay, we don't know what the z-score is, but we're given the area or the percentage or whatever, and we're going to use our chart to try to work backwards to figure out what that value is. Now, remember our formula is the value for our z-value minus the mean divided by the standard deviation. We were able to use that to figure this out. Notice we multiplied by the standard deviation and then added the mean on. Well, this formula here just does that automatically. Instead of solving, this is just a variation of this. Our value, to find the value we're looking for, you take the z-score times the standard deviation plus the mean. So, working backwards now. We're given a percentage or a probability that we want under the standard normal curve. And we've got to use that to find our z-value, like we did here, and then plug it into the formula, whether you do that or this new formula, to be able to find the value that we are looking for.